I would like to use these questions to explain the concept of resultant and equilibrant. Now, the two forces, 3 Newton and 4 Newton, act on a body in direction due north and due east, respectively. Calculate their equilibrant. But before we can calculate equilibrant, we have to get the resultant first. Now, they say two forces, 3 Newton and 4 Newton, act on a body in the direction due north. This north. So that's 3 Newton. This is a body. So this is a body. 3 Newton north and 4 Newton act on the body in direction. 3 Newton and 4 Newton act on the body in direction due north and due east. This east. 4. They calculate this north and this is calculate their equilibrant. So before we can get equilibrant, we have to get resultant. And how to get resultant? Resultant is always the single force. Here. It's always single force acting that has the same effect on both magnitude and direction. So always common. So like I told you, the formula for the resultant is when it is up, it is forming 90 degrees like this. We use Pythagoras formula. R squared equals to F1 squared plus F2 squared. So the resultant 3 squared plus 4 squared. 3 squared 9 plus 16. That's 25. The resultant is 5 Newton. The square root of 25 is 5 Newton. The resultant is 5 Newton. Anytime you are dealing with this kind of questions, you have to find the resultant and directions, magnitude and directions. How do we find the directions? Anytime you are looking for directions, we use tan theta. So tan theta, if I cover this triangle like this will represent my y, and this will represent my x. So tan theta equals to y over x. That's the formula for the directions. And what is my y? This is my y. The angle is always acting at the direction of x-axis. It's my x-axis. You cannot put it here. Anytime you are finding direction, you always act it at the direction of x-axis. That's why I put it here. So, and this, any way that the angle face is our opposite. So our opposite is y. That's why I put it, because I use tan. We always use tan in finding directions. 12. So our opposite is here, y. That's why I use, and the adjacent is here, x. So, what does that mean? That means our tan theta is our y is 3 because this line is always equals to this line. That's 3 over what's our x 4. That means our tan theta equals to now 3. Let's use our calculator. Divided by 4, that's 0.75. Regardless of our time. So theta, so shift tan 0.75. So that will give us our tan, our theta is shift tan 0.75. So shift and 0.75, 36.87, 36.87. So to take a significant figure and it is 6.8 degrees. Now that is our. Now don't forget that we are actually looking for equilibrant. We are not looking for resultant. Our resultant is 5 Newton. In which directions? In the direction of what? 36.87 degrees. But how do you write it? You want to write answer for this? You want to write answer for this? He said resultant equals to 5 Newton in the direction of what? North, because we are talking about north and east. North 36, or if I want to say in the nearest degree, that is 37. North 37 degree west. North 37 degree west. There's nothing like west 37 degree north. The two reference points we have is north and south. North and south. So that means you are going to, that's north 37 degree west in the nearest degree. Now, what's now equilibrant? I told you that equilibrant, according to the definitions and the explanations, equilibrant is always the same in magnitude with the resultant. That means equilibrant also, E is also what? 5 Newton. But in opposite directions. That means if this one is north, what's the opposite of north? South. 37 degree. If this one is west, what's the opposite of east? So that is equilibrant. So that is according to the explanation we did the other time. That means equilibrant, it is always the same in magnitude with the resultant, but in opposite directions. And is a force that counterbalances other forces. If you check the our explanations that we did. Now, let's just talk about the triangular forces.